coefficients equations in terms of this. Okay, so you will take a substitute so that it will transform to this form, and then we know how to solve this type of equations, and we will solve this. Suppose I am and this type of equation is called Euler-Cauchy equation, and we will solve this type of equation. We will put a substitute x is equal to e to the power z, or z is equal to log x. Okay, so dy dx will be replaced by, so your dz dx is from this, is, you know, is that means x dy dx will be dy dz. Now so I will substitute this, and that means x square d2i dx square will be similarly we can prove the dx of the last term was 1 by x square. Okay, again differentiating with respect to ddz, and there will be dz dx will be 1 by x, so that will be nothing but 1 by x, 1 by square. Minus 2 by x square. X square. This is cube minus this is 1 minus 1 minus 2 minus 3 into the square plus 2 d into z minus 1 by x square. So minus 1 minus 2. Okay. So if we our ddx was denoted by this, suppose I denote right. So I can replace this. What was your x? Your x dy dx was dy dz. So x dy dx was dy dz. So I can write this as d dash d dz d dash y. X square this was d2y dz square minus dy dz. So this can be written as d dash d dash minus 1. Similarly, this can be written as third, this can be written as this is d dash cube minus dd square minus minus 2d square, that will be minus 3 d2y dz square plus 2 dy dz, that will be operated on y minus minus a plus 2d dash y. So I can write x to the power n dny dx and write d dash minus 1 d dash minus 2. What will be the last term for n?
D dash
n
minus
minus 1
1.
D dash minus n plus 1.
plus 1 n plus
Oh.
This will be operated on y. Okay. So we will, whatever equation we have got, now we can write this in terms of d dash, and we will find out differential equations with constant coefficients, and we know how to solve those type of equations. So we will now solve one of those equations so that the method is okay. I am starting with a simpler problem, and it's simply the same solution, same type of solutions, but you have to just first transform the equation in the form of, suppose you have to solve this type of, okay. So your form of, you will take your x is equal to e to the power z. So your z is equal to log x. Fine. So this will be d dash minus 1 minus this will be x d dash is 4ds plus 6. It will be operated on y. This is what will be log x square 2 log x, that means 2z. Okay, since I am transforming the operation in terms of z, so our this right hand side is also to be shifted to in form of z. Okay, so you know how to solve this type of equations. So this will be uh, d dash square minus d minus 5d dash plus 6y is 2z. Now you know how to solve this type of equation, your auxiliary equation. This will be the same procedure, only your d dash will be d by dz. So your solution will be in terms of z and y, because you are operating on y. So this is your auxiliary equation will be m square minus 5m plus 6 is equal to 0, m is equal to 2 and 3. So your complementary function of this equation will be c1 e to the power 2z plus c2 e to the power 3z. I have to substitute this z in terms of x because I have to solve this equation in terms of y and x. So your C1, this is your y, CF is y, basically CF is some y. C1 e to the power 2z is nothing but, what is your 2z?
X square.
Your z is equal to log x. So what is your 2z?
X square. E to the power 2z will be
Hi, e to the power 2z will be x square. This will be 2 log x, okay? So e to the power 3z will be C2 x cube. Fine. So you have got your CF of this given equation. We have to now find out your PI. You know how to find out this PI is 1 by d dash square minus 5d dash plus 6 is operated on right side is 2z. Okay. We know if this is a polynomial, so we will write this as 1 by 6, 1 plus d dash 6 2z is equal to 1 by 6, 1 plus, okay, I can say this will be 1/3. Now this expansion is 1 minus nx. Okay, I am not taking the higher order terms because it will be operated on z only. So the higher order terms will vanish. Z, this term won't exist, plus 5 by 6, that will be right. So this will be 1/3. What is your z? Your z was log x. So what is your complete solution? Y is equal to CF plus PY. CF was C1 x square plus C2 x cube. So your solution is C1 x square plus C2 x cube plus 1/3 log x plus 5 by 6. Okay, and I hope you have solved these type of problems that was given, whatever given was in the example or the exercises, the all types of your, this function may be polynomial, this function may be in terms of e to the power or in terms of sine cos or some product of some x function and some e to the power or something, like there will be various combinations it can happen. Okay. So, I hope you have understood the process. Uh, okay, I am giving you a simple example to solve so that I do understand that you have. Mm, okay, just one sec. Okay, tell me x square d2y. Okay, you put x is equal to e to the power z, j is equal to log x, and then solve it and tell me whatever the result you got. I hope you understood the process, the previous one, so then you can easily will be able to solve this. Have you found out the complementary function?
Yes, ma'am.
Okay. And so you have got this c1 plus c2 log x
Yes,
multiplied by x square as your complementary function.
yes, ma'am.
Yes, ma'am.
Okay. Then find out the pi, particular integral.
Ma'am, is it x to the power 4?
No, your pi is z square e to the power 2z.
Ma'am, x square.
Z
No,
square to the power 2z.
z square e to the power 2z. That means z square means it is log x square and e to the power 2z means x square. So your complete solution will be this CF plus this. This is your PI. So your complete solution will be this. You have got this as your PI.
Yes, ma'am.
Okay. Anyone have any problems with this finding this PI or
ম্যাম বলছি ডি ড্যাশ মাইনাস টু তার হোল স্কোয়ার আছে ডিনোমিনেটরে, তো ওটাকে দুবার ডেরিভেটিভ করলে আমি 2 পাবো। ওই প্রসেসে এগোনো যাবে না?
না 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 আচ্ছা এটাকে তুমি কি করেছো এটা এটা দেখো তলাটা তুমি কিভাবে করেছো এটাকে তুমি 1/d-2 এটা 2 e to the power 2z। আচ্ছা আমি যেটা বলতে চাইছি তুমি যদি আমাদের নর্মাল যে ফর্মুলাটা ছিল e to the power ax টাকে 1/f এ বসাতে পারতাম, এখানে তো ভ্যানিশ করে যাবে, তাহলে আমি
হ্যাঁ
ওই ফর্মুলাটা অ্যাপ্লাই করতে পারবো না।
হ্যাঁ, ভ্যানিশ করে যাবে বলে আমি ডেরিভেটিভ করবো আর ওপরে এক্স নেবো। প্রথমবার ডেরিভেটিভ করলে ওপরে একটা এক্স পাবো, নিচে টু টু ইন্টু ডি ড্যাশ মাইনাস টু আসবে। নেক্সট টাইম আবার
হ্যাঁ।
ডেরিভেটিভ করবো, ওপরে এক্স এর স্কোয়ার আসবে আর নিচে টু ডি ড্যাশ আসবে, খালি টু আসবে, দিয়ে ওপরে দুটো টু কেটে যাবে ওপরে আর নিচে, ই টু দি পাওয়ার টু
আরে
জেড মানে এক্স
ওটাই তো
স্কোয়ার আর একটা।
বেসিক্যালি ওটাই তো তুমি আমরা এটা করেছি দুবার ইন্টিগ্রেট করে, তুমি ওটা এক্স স্কোয়ার কেন আসবে? তোমার তো ডিপেন্ডেন্ট ইন্ডিপেন্ডেন্ট ভ্যারিয়েবলটা জেড, ওটা জেড স্কোয়ার বাই 2 আসবে আসলে।
ও ইয়েস ম্যাম, হ্যাঁ হ্যাঁ হ্যাঁ, জেড স্কোয়ার আসবে, সরি।
ওকে, বেসিক্যালি তুমি ওই যে ডেরিভেটিভ করছো আসলে ওই প্রসেসটা আসলে তুমি ওই একবার করে ইন্টিগ্রেট করে আর একবার করে ওটাকে পাচ্ছো, মানে ওটাকে শর্ট ফর্মে অনেক জায়গায় ওভাবে লেখা থাকে। ওকে ফাইন, তাহলে ওকে সো ইউ হ্যাভ আন্ডারস্টুড অল অফ ইউ দ্যাট দ্য প্রসেস। ওকে ফাইন, সো সাপোজ I have a problem like acha, before we have taken x is equal to e to the power z, now we will take this is equal to e to the power z. So your z will be,
And the first will be 1 plus 2x whole square.
okay, right, yes, that will be whole square. And you can easily see basically these are in forms, otherwise it is not easy to substitute. Suppose you have something multiplied with some other form and there is not in form of 1 plus 2x, then you won't be able to formulate this equation in the given form. So what we do, we try to solve the differential equations. The method we already know, and if we don't know, maybe some other method we can apply, maybe not applicable at all. Okay, so because since I have this form, say a plus bx, so putting in place of x e to the power z, I am putting this is equal to z. Okay, so you know how to now differentiate. Your dz dx will be 2 by 1 plus 2x. Basically, this term will be nothing but b, whatever your b dy dx. So the next term will be d2y dx square will be d dx of this is your 2 1 plus 2x dy dz. Okay. So this will be nothing but I can and plus dy dz into minus of 1 by 2x whole square into 2 into 2. Okay, so I can simplify this as 4 1 plus 2x whole square d2y dz square minus dy dz. And if you remember, the formula is that was x dy dx was the, and here the term is first is 2 and another will be 2 square, that is 4. The another term will be 2 cube, that is the third order. You will get a 8 1 plus 2x whole cube, and the terms, that is whatever we have got, d cube y minus dx cube minus 3 d2y. So that is the same form, just we will have a term here, the multiplied with the. So I can write this 1 plus this is nothing but 1 plus 2x square d2y dx2 will be 4 into this equal to 4. So in general, whatever your p is, you will always get in term of 2 b square of d dash minus 1. For third, you will have a b cube d dash minus 1 d dash minus 2. You will always get the same formula. So my equation is 1 plus 2x square d2y dx square, that is, it is nothing but 4 d dash square, I mean d dash square minus d dash operated on y minus the next was 6 into 1 plus 2x dy dx will be 2 into 6 means 12. 12 d dash y plus 16y is equal to 8. It was 1 plus 2x whole square, so e to the power 2z. Okay, so we can simplify this. I can cancel out this 4. So this will be square minus d minus, this will be 4 12 4 d dash plus 4 y is equal to 2 e to the power 2z d dash. So your CF is C1 plus C2z e to the power 2z, and just the previous one, I think we have got this right part, right? E to the power 2z, you have just solved this pi 1 by d minus 2 whole square 2 e to the power 2z, so you know the already solution. This will be z square e to the power 2z. Okay, and I am not solving it again because you have just already solved in the previous problem. This was z square e to the power 2z. So we will replace this, our 1 plus 2x was e to the power z. So I will replace this, CF will be C1 plus C2 log 1 plus 2x. This is multiplied by 1 plus 2x square, and your pi হচ্ছে your z square is log 1 plus 2x, and e to the power 2z is nothing but 1 plus 2x square. So your complete solution will be CF plus PI. So it will be the same way. You have to just substitute uh, in respect of a plus bx is equal to your z. So you will get the solution in this form, the previous one like before. So you will be able to solve this type of problems also. So these are how to solve homogeneous linear equations with variable coefficients. And obviously all the problems will fall into these two categories. Either it will be in terms of x to the power n dny dxn, or in terms of a plus bx whole to the power n dx dny dxn. So you will be able to solve this type of problems. Okay, I have given you the exercise already in the PDF, so you have to try and solve those one. Okay. Now method of variation of parameter for solving a second order linear differential equation. Basically, we have already solved second order linear differential equations with constant coefficients by the methods we know, and there are another methods. In fact, this is not only the method, there are other methods, that is like undetermined coefficients, or from if a solution is given, finding the other solutions. So, but only this method is in your syllabus, and this is very important method. Sometimes probably we won't be able to solve in the given or in the previous problems, like we try to solve in other forms also. Sometimes whichever is applicable to you. Suppose the problem is given, if not mentioned the method you have to apply, you can solve any differential equation in any method you know. But first you have to learn the method, that is method of variation of parameter. Okay, you can understand because it is using the term variation of parameter, so that means we will vary some parameter in the given problem, so that I will be able to solve, we will get a solution for a given differential equation, and it is for second order, but we can apply this method for higher orders also, but that method will be little bit complicated. So we will only solve the second order equations. Okay, you know second order linear differential equation, you already know. Okay, here we have already solved for the equations with constant coefficients, with now I will say these PQ are not constants, they are functions of x. This x also. These PQX are functions of x. So we have to solve these equation. Now we know this is the homogeneous equation for this equation, and we will find out the complementary function from this equation, and we know how to solve this. Suppose I am writing this as AU plus BV, where your A is constants, B is constants, and U and V are functions of X. And you know, we have already solved how to find out the complementary functions, we know. So we will get a solution that is a complementary function in this form where A, B are constants and U and V are functions of X. Now, what we now try to solve, that is, now we assume this A is not constant, that is, I am varying the parameter, and B is also a function of X, such that this is a solution of this given differential equation. That means whenever we find out the CF, then we have calculated the PI, okay, from this equation. Now what I am trying to say, we have find out the complementary function, but unlike previous cases, these A and B are not constants, they are now functions of X, okay, and such that that means we won't calculate particular integral, otherwise we will solve it in terms of these A and B and we will get the complete solution for this equation. So I am assuming this is the solution of our given second order differential equation. That means this equation will satisfy this equation. We have to find out this A and B because our U and V is already known from the homogeneous equation. We have already calculated U and V. Now, so what will be dy dx is, I am writing this in AX here because I am just trying to emphasize that it is a function of X. Otherwise, I can always write this without a, because I am not writing U in terms of X only, but for the second time I am writing this, and uh, this is differentiation, then U dA dx plus B dV dx plus, and please, if I do anything wrong in the calculation, please let me know. I do some silly mistakes always. Okay, so I think I have done the differentiation properly. So now we will find out A and B. That means we will choose our A and B in such a way that this is 0. That means your U dA dx plus V dB dx. We will choose our A and B in such a way such that this condition is satisfied. That means this term will vanish. So I am writing my dy dx as A du dx plus B dv dx, because the other term already vanished. I mean, I am writing because it is in the first page, but I have taken this is equal to 0. Okay, so this is term is 0. So my dy dx is this. So d2y by dx2 will be, okay, this is, if it is my dy dx, So my d2y dx will be this. Now, since I have taken this is our solution of the given equation. So putting the value of this dy dx, d2y dx to y in the equation, that will satisfy the condition. So I am putting this value of these three in the given equation. That is, my given equation was d2y dx2 plus p dy dx plus qy is equal to x. That was my given equation. I am putting this value, that is, I am putting d2y dx to this, dy dx this, and y is this. And I am summing. Okay, I am not writing down the terms here. I am summing and writing down the sum. So this is a d2y dx cube plus p dy, so that will be multiplied by p du dx plus, there will be a term in u qy, so this will be qu plus right. Okay, this is true. Now we know this is 0, this is 0, because your u and v was the solution of the homogeneous equation. So definitely this should be 0, this should be 0. So I am left with this du dx, a right hand side, this. So I have got two equations, that is, one is u dA dx plus v dB dx is equal to 0, and another is du dx dA dx plus dv dx dB dx is equal to x. And I can solve this equation okay. You know how to solve this equation, so this will be minus vx 0, that will be cancelled out, and this will be u ux minus 0, and that will be 1 by u dv dx minus v du dx, right? Is it okay? So Are you following?
Yes, ma'am.
Okay. So this is capital X. So I will get my A is integration of this and one arbitrary constant, and similarly B will be integration of ux dx by u dv dx minus v du dx plus C2. So now I know A and B. So our complete solution will be AU plus BV, and since this A contains one arbitrary constant and your B contains one arbitrary constant, so there are two arbitrary constants C1 and C2 in solution of the second order differential equation. So this will be our complete solution. So I will put the values of A and B here, and we already know our U and B, so I will get the solution. So these terms method of variation of parameter, because I am varying these two parameters. Okay, this is not constants, we are varying these parameters and we will got the solutions. Okay, now you know the general method. Now you have to solve your problem. That is, so this is d2y so your x is here. Okay, so we already know your, this is your m is plus minus ia. So this is complex. So your y is cf is y is a cos ax plus b sin x. So this is our u and this is I v. Okay. So now we will assume the solution where A and B are not constants. Okay. So we will now, again we will differentiate with respect to x, and we will get cos ax minus a sin x plus a e cos ax plus sin dx. Okay. Now we will choose our A and B in such a way. Okay. So আমাকে আরেকবার ডেরিভেটিভ করতে হবে। ওকে, dy dx টা, okay, I have to write down here. dy dx is minus a sin x plus ab cos x. So I will integrate with respect to x another time. So this will be minus a square cos x minus a sin ax dx plus a cos ax dx and minus a square b sin x. Okay. Now putting this value of dy dx, d2y dx2 and y in the given equation, since our y is equal to au plus bv is a solution, so I will put this value. Our given equation was d2y dx square plus a square y is equal to sec x. So I am putting this here. That will be minus a square cos x minus a sin ax dx plus a cos plus a square into y. Our y was plus a square into a a cos x plus b sin x. A cos x b sin x. This will be is equal to sec x. Okay. Now I can see, or a square a cos x, okay, a square, this will cancel out, a square b sin x, this will cancel out, okay. So only there will be minus a sin ax dx plus a cos ax dv dx is equal to sec x. So we have to solve these two. Okay, this equation is nothing but this equation, a cos ax dx sin ax dv dx. Okay, so it's a cos ax dx plus sin ax dv dx, and the second equation is this one, sin ax dx cos ax dv dx multiplied with a 1 plus and 1 minus. So that will be minus a sin, okay, minus a sin dx plus a cos ax dv dx is equal to 6. Okay, so this will be 10 minus 10 x. Okay, so this will be this plus 1, and this will be cos square sin square. Okay, A. 10 মানে হচ্ছে log sec x. Okay, fine. So that will be minus. So this will be plus 1 by a log cos x plus c1. B is equal to 1 by a x plus c2. Okay, so our solution I am writing here only. Your solution y is equal to ax u plus bx v. So your ax is his 1
So
by
the
a.
এটা 1 by a square হবে না? ম্যাম?
এটা s. Oh, that there will be another a, right? Integration. Right, this will be 1 by a square. So 1 by a square log cos x plus c1 into your u was cos or sine. A cos x ছিল, right? So that will be cos x, and your b is this x by a plus c2, and v was sine ax. So you will just multiply and simplify this and you will get the result. Okay. So this is your complete solution of the given second order linear differential equations, and your arbitrary constants is C1 and C2. Okay. So this method is little elaborate, but it's same the easy thing, I think. If you do practice, it will be easy for you.
Ma'am,
So
can we use the direct formula to derive the value of A and B, or we have to just describe whatever you have done in the class during the
direct
new
formula
solving?
means you are trying to use this from this dA dx is equal to, so you can you wish to integrate directly. Okay, you can do it, no problem.
Okay, ma'am.
And if suppose your problem is for 7-8 marks, then you have to calculate the steps. Okay,
Okay, ma'am.
if it is in for short 4 or 5 marks, then you won't have to do it. Okay, so this is okay. Can I give you an example and you can solve? Okay, so you can try. I'm trying to give you a simpler one so that. Okay, will you do the next class on 24th?
Yes, ma'am, no problem.
No problem. Okay, fine. Then I don't have any problem. I'm finding the problems for method of variation of parameter. Okay. Okay, try this one. Okay, and one thing, we will always do the second order, because suppose I have a third order equation, then I have Okay, so I have to start with this type problems for third order. So it will be a little more complicated. And in general, you will have only the second order differential equations, but this method can be applied to also the higher orders. Okay. So now solve this by method of variation of parameter. It is, or method is described by method of. And remember, we don't know the formula for anything for finding this PI. Suppose I have to find out, so we don't know any general formula for this type of functions, PI. So we have to integrate separately for finding out PI. If we have used the previous formula. But for method of variation of parameter, this type of functions is easier to solve.
If anything is not told, then we can do in any method. Means like
Right.
that.
If anything is not mentioned in your problem, then you can use it. But I am
In
telling
particular, in
you, since your other methods is independent, this method is slightly different. So for solving method of variation parameter problems, always the method is mentioned. Okay. So in your question paper, maybe there will be one problem already mentioned in this method. That is, you have to use this variation of parameters. Otherwise, you can solve it by any method.
ma'am, the answer.
Okay, whatever you got, your A or B. Tell me what you have got as your y is A cos 2x plus B sin 2x, right? Or you may be A sin 2x, B cos 2x, I don't know. So you told me whatever you got for your A and B. What you
Ma'am,
have got as your A? Tell me what is your A?
minus ln of sec 2x plus tan 2x.
Okay. There must be some constant or something like that. Your A is this
Minus 4 sin minus sin 4x
minus
by 2 minus sin 4x by 2.
sin 4x by 2, and your B,
B is sin only sin 2x, means it is a1. It is coming.
it is only sin 2x.
No, ma'am. B sin 2x, it is coming only sin, means sin 2x. Total means 1 it is coming. I
B
have
is
done
1.
in
No,
another form.
no, B will be function of x. It can't be 1.
C1 minus cos 2x.
This is minus cos 2x, right? So there will be another constant here. So this A is everyone is satisfied with this A. Everyone is satisfied with this A. I think this should be sin 2x. This term is not. I am saying the answer is plus sin 2x.
Plus
This is
Ma'am,
plus
it
sin
is a
2x.
plus sin 2x plus sin 2x.
Yes,
This
ma'am.
will, okay. So now you know your A and B. So you know your A. You will put this into cos 2x, this B into sin 2x, and that will be your answer for a complete solution. Okay. So you do practice with the exercises, okay, for both method of variation parameter and homogeneous equations with variable coefficients. Okay, next class we will do some simultaneous equation, and your ODE will be, that means ordinary differential equation will be finished, and I will start with PDE, partial differential equation. Okay. Okay, next class on 24th, that is next Thursday, this 10:30. Okay.